Oh.
All right, so if we have a right triangle and we draw the altitude down from the where the right triangle is to this hypotenuse down here, it will form another. It will actually form two smaller right triangles. And theorem 9.1 says this. I'm going to label this A, D, B, and C. So theorem 9.1 says if the altitude is drawn to the hypotenuse of a right triangle, all three triangles are similar. So that's pretty cool. So in other words, we can say then the triangle ABC is similar to triangle CBD, is similar to triangle ACB. And, so the quiz that you guys just took, I asked you to state whether or not the triangles are similar. And so if you say they are similar, it's important that you put the points, the vertices in the correct order, right? And so you'll notice with this one here, ABC, this has to be CBDs in order to actually show that's the triangle that's similar to ABC. Likewise, we have to call the other one, we have to call these in the same order. So in other words, point A on the big triangle has got to correspond to big point C on this triangle that's right here, and it's got to correspond to point A on this triangle that's right here. So our triangles, if we drew them all, would be they would be like this would be C, and so this would be A, and this would be B, like that. So we have the big one that looks like that, and then we've got a medium-sized one that looks like C, B, D, and then we've got a smaller one that looks like A and C and D. Right, so those are all of our triangles if we were to draw them out side by side. So that's something you got to be able to figure out in your mind as you're looking at these. How you're kind of flipping these so that you're able to line them up correctly. One of the things that's helpful when you've got a drawing like this is think about the sides that are the longest side and the sides that are the shortest sides. Right? So that'll help you kind of identify the correct order. So notice with this one here, for our small triangle, did I draw that right? Let me look. For a small triangle, BD should correspond to CD, should correspond to BD, should correspond to CB, yep, so this is the shortest side on this little triangle, this is the shortest side on the big triangle. So DB is right here, there's DB, it's just written backwards, but DB has to correspond to CB in the big one, right here, and it's got to correspond to CD and this triangle right there. So did I do that right here? Let me see. CB corresponds to. Wait a minute, I did something wrong. Sorry guys, hang on just a second. This is supposed to be DB. I wrote them out of order. My bad. This is C. This is the medium-sized triangle. It's right here. So D, C, and then A. There we go. Sorry about that. I was looking at this, the order that I wrote them in down here, but then I wrote them because they're not. This is actually the smaller triangle. They're kind of written. This is large, small, medium. But then when I drew them in order, and from largest to smallest up there, I didn't label them correctly. So I'm sorry if that confused anybody. Did you guys follow that now? You see how it's helpful to look at the small, identify the small side, and then identify the long side. If you're looking at a right triangle, what's always the long side? The hypotenuse, the side that's opposite your right triangle, right? So that's the long side is always easy to identify. Does that make sense to everybody? Any questions about that? Okay, so they give us an example 1, where we're trying to find the roof height, and this is on page 528. So we're given this roof that looks very similar to our drawing here, right? Where you've got a right angle here, and they've got a line drawn down here. They give us a right angle here, and so they say this is 5.5 meters. And this is 3.1 meters, and we don't know this height here, and they tell us that this whole thing is 6.3 meters. And they've labeled it ZWX, ZWX, and then Y up here. And so they say identify the similar triangles. So the first step would just be to do what we did over here, where we draw our triangles. Like I said, I think it's helpful to just sort of do them in order, from largest to smallest, or smallest to largest, something like that. We know all of these are going to be right. Triangles down, right angles down at the bottom there. And so when we look at the big one, what side is our shortest side on the big triangle?
XY.
It's XY, which is 3.1 meters, right? So we could say this is Y here, and this is X, so 3.1 meters. And if that's X and Y, then this has to be Z up here. And so we've actually got this identified on here as well. This is 6.3 meters. And our other side, our medium length side, is the 5.5 meters. For our medium-sized triangle, we can see that the right angle is down here where W is. What's this point here? From on the other side of the shortest side from the W? Count?
Y.
That's Y. And so then this is going to have to be Z up here. And we could write down any of those that we have values for. Do we have, let's see, all we've really got is Y to Z, which is 5.5 meters, right?
H.
Yeah, that's right. We have H labeled right here. Who said that? And then for our little guy, he's so cute. 3.1 meters right here. So we've just got W, X, and Y, and we've also got H labeled there. Let's see, I did something wrong though, didn't I? I did. This is supposed to be H right here on our medium-sized one. So did I lose anybody as I went from this figure to these three separate triangles here? Everybody follow that? It's important that you can do that, right? You got to be able to rotate these in your mind and think about how these are laid out in order to solve these problems. And so these are the similar triangles. So we could then say the triangle, we could start with any point here, but now that I've written them out like this, it's really easy for me to make sure I don't make a mistake and say I can start here and say go up and over like this. So I can say triangle YZX is similar to triangle WZUY is similar to triangle WYX, right? And of course your answer may be slightly different from mine. If you decided to start at this point and go that direction, then that's fine. As long as your points line up, then you'll get credit for that. And so the last thing that they asked us is to find the height. So we're trying to find h here. So how would I find h? Who wants to give me, whose name is not on the board, who wants to give me a way that I could calculate h? They're similar triangles, right? So I know all of the sides on the lengths here, so probably makes sense to use this triangle and maybe this little guy down here. I could do that. So I could say 5.5 over h has got to be equal to 6.3 over what? 3.1. Did you say that, Gabe? Okay, so it's got to be the same as 6.3 over 3.1. Right? Those ratios have to be the same. And so then I'm just cross multiplying and I'm saying that 6.3h is equal to 5.5 times 3.1. And if I had a calculator, which is right now we're recording the lecture, I would be able to figure that out. But I've got a classroom full of calculators, so you guys are going to tell me that h is equal to...
17.05.
What'd you get?
17.05 is what you get.
17.05. Did everybody else get that?
That's 5.5 times 3.1.
Oh, that's this one.
Yeah.
Okay, 17.0. So she did this, and then when you divide both sides by 6.3, to get rid of our 6.3 here, we get h is equal to what?
It's a lot of decimal places.
It's a lot of decimal places. I hope, though, it's a lot of decimal places that round off to 2.7.
Yes.
Okay, good. So 2.7 what?
Meters.
Meters. And look, do you see what I did right there? I circled my answer.
Whoa.
See that? It was a lot of work, right? It takes skill and practice, but you guys can do it. I'm confident that you guys can do that. If you're not good at comfortable with circles, a rectangle works just fine as well, okay? Or at the very least, just an underline there. I'll take that.
Or you can do all of them.
A star,
I
something.
feel like he's trying to pass.
He seems to be speaking words of some sort.
Mr. Walker,
Yes.
can we even do a triangle?
A triangle, that would be great. I like that. That would be perfect for this type of problem. All right, very good. Nice idea. I might even put a little smiley face on there if you try and get your answer for a problem like this. Right? I know how much you guys love my smiley faces when I put them on there. All right, so let's any questions about this? Everybody got it? Cool, tracking with me? Good. Let's talk about theorem 9.2. We're just going to do that over here so we can use the same figure that I've drawn. So theorem 9.2 says that in a right triangle, the altitude from the right angle to the hypotenuse, doing some abbreviating here, so let me know if I lose you, divides the hypotenuse into two segments. Duh. All right, so this is kind of weird. You got to remember geometric mean. The length of the altitude is the geometric mean of the lengths of move this. the lengths of the two segments. In other words, altitude squared equals long part of hypotenuse times the short part of hypotenuse. Or you could think of it as altitude squared equals, if you think of this as forming two legs, altitude squared equals the long leg times the short leg. I might actually say that. Scratch that last part. Because we're going to use the leg. We're going to speak about something else as the leg, so don't write that down. Just forget I said that. So what does this actually mean when we think about our figure right here? It means that BD over CD equals CD over AD. So BD over the altitude equals the altitude over AD. And so you'll notice if we cross multiply with this, what do we get? Well, we get CD squared equals BD times AD, which is what we have right here. The altitude squared is the long part of the hypotenuse times the short part of the hypotenuse. So that's where we get that from. So you could either remember this, right? Or you could remember this right here, whichever way is the easiest way for you to remember. But does that make sense to everybody? Do you understand what I've written down? Any questions about it? At the end of the day, it's just a formula, and you got to make sure you can plug in the values for this formula.
I'm jamming after that.
All right. So while we're on this topic, I'm going to go ahead and write down theorem 9.2 using the same figure. I have to write it over here so that I have enough room. And I guess I'll just write it. I'll break out of my normal routine of leaving space in the middle. I'm just going to write it next to it because that's where our figure is. So theorem 9.3 says this. In a right triangle, the altitude from a right angle to the hypotenuse divides the hypotenuse into two segments. That's the same thing that we said in the last problem. The length, here's where we use the term leg. The length of each leg of the right triangle is the geometric mean of the lengths of the hypotenuse and the segment of hypotenuse adjacent to the leg. In other words, let me draw a little box here so we don't get them confused. It goes with that. This is its own little thing right here. So i.e., in other words, length of long leg squared equals long part of hypotenuse times whole hypotenuse. Or and length of short leg squared equals that can't be right. That's got to be short hypotenuse. My notes were wrong there. We can fix that. All right, that's kind of a long one, and if we think about our same figure, where we get this from is that AB over CB equals CB over DB, where CB is the short leg right here, right? So this is, you can think of this as the short leg. You can think of this as the long leg. You can think of this as the long hypotenuse if you wanted to. This is the short hypotenuse. If that helps you. If it confuses you, don't worry about that. But basically, AB over CB. So in other words, the whole entire hypotenuse of our big triangle over CB, which is this short leg, is going to be equal to the short leg over the short hypotenuse. The short part of the hypotenuse when you drop down the altitude there. And so that gives you this formula. And the other one is going to be AB over AC equals AC over AD, which has to do with the long side. So the entire hypotenuse over the long leg is going to be equal to the long leg over the long part of the hypotenuse that's created, which gives us this formula here. So if you have a diagram that looks like this, you could rewrite both of these formulas as, you could write this one as the long leg squared equals long part of the hypotenuse times the whole hypotenuse. If you had double H, that stands for whole hypotenuse, not Waffle House. Just make, I know it's a bummer. And then the length of the short leg squared equals the short hypotenuse times the whole hypotenuse. So you could think of it like that, and you might want to, if you want to draw a little diagram on your notes, maybe draw something that shows that this distance here is the whole hypotenuse. Right? If that helps you kind of shrink it down so that you can fit it on your note card. Again, the main thing is that you understand these formulas, right? That you get this formula here, and that you understand this formula here. We could rewrite this formula here as the altitude. That's not an AH, that's the altitude. The altitude equals, so we could say, based on the way that we've labeled it now, we could say altitude squared equals long hypotenuse times short hypotenuse. So you could write it like that. So does anybody want to run screaming from the room yet? Me too. This is a lot to write down, right?
Well, I like to do that when I room.
Do what?
I like to do that when I exit the room anyways.
Oh, okay, that's good. That makes sense.
It's not just because of your class.
Okay. Thank you. I appreciate that.
Oh my goodness, that's just
So it's a lot to write down, right? This is our figure that goes with all of these theorems. Let's actually do a problem, and we'll see that actually we're just plugging in a formula, right? As long as we know these formulas here, this isn't hard to do. That's just what the theorems say, and I think once we do a problem, that it'll be less confusing when you see what worked out. Okay, so let's do this. We're going to say this is a right triangle. We're dropping down an altitude there. We have value 6, and we have value 3, and we have value x right here. And they say find the value of each variable. So which of these theorems, if we've got this value and this value here, which of these theorems is going to help us find the length of the altitude? Which one? 9.2, Liana says. So let's see, Liana said, the 9.2 says that the altitude squared is equal to the long hypotenuse, the long part of the hypotenuse times the short part of the hypotenuse, right? So altitude in this one is what?
X.
It's x, right? So x squared equals, the long part is 6 times the short part, which is 3. So x squared equals 6 times 3 is 18. So x equals the square root of 18. And we can pull a 9 out of that, and we can say that it's 3 times the square root of 2. Now, we said a lot right here, but wasn't that really easy to do?
Yes.
Right?
why
So it's
didn't we just do that?
right. Well, that's. I wanted you to see the theorem.
I didn't even I was like, what are we trying to get? And I don't understand. Just a bunch of words
Yeah.
put together.
Yeah. Well, here's the thing. Here's why I wanted to write down the words is because some people. We just learn differently, right?
Yeah.
So some people will read the words and they'll go, oh, okay, that makes sense to me. Whereas if I just wrote down the formula, they wouldn't have connected the dots. So just trying to make sure that whatever way you learn that you get it. But this is all that it means at the end of the day. Can you plug in those values and use this formula, right? And so let's do one more problem. Any questions about this? Did I lose anybody in doing that? It's pretty straightforward once you do it, right?
Yeah. It's like playing a game. Some people get the instructions, and some people just have to do it.
Exactly. I'm with you.
I just
I'm with you. So let's do this other one. So this one we draw the triangle a little bit differently, but the idea is exactly the same. Anytime you see this right triangle here, and then you've got a line drawn that forms the right triangle over here, you know you're dealing with these types of theorems, right? And so this one says y, 2, and 5. And so if we just think about this triangle, given the little sort of simple labels that I put on our triangle over here, what does y correspond to in our drawing over there?
The short leg.
The short leg, right? So SL equals, were you going to say that, Cameron? Who raised their hand? Was it Camille?
Mhm.
Were you going to say that?
Yes, sir.
Okay, good. So I'm glad you were going to say that. What about the 2? What does the 2 correspond to?
The short side of the hypotenuse.
The short side of the hypotenuse. So this is the short side, right? And then what is the 5?
The long side.
It's the long hypotenuse. So which theorem is going to help us figure out what SL is?
9.3.
9.3.
Specifically this formula in 9.3. Yes?
Would it also work if we said y was the long leg? Would it be the same? Would it give us the same answer? Because it looks like the legs are very similar.
Well, we know it's not, though. We know that's not the long leg because we know this is the shorter hypotenuse. So the shorter leg will always correspond to the shorter side of the hypotenuse.
That makes sense.
Okay? So we can use this one here. We can say SL squared equals short hypotenuse times the whole length of the hypotenuse, which we can figure out. So we've got y squared equals 2. The whole hypotenuse is 2 plus 5, right? So this is going to be 7. So y squared equals 14. Y equals the square root of 14. So super easy to plug in, just super hard to write down, right? I was really just testing your resolve. Were you going to stay awake all the way through that? And you guys did pretty good, although Mary looks pretty close. She's like, I should have brought coffee to class. Are you a coffee drinker, right? Okay, yeah. I didn't get much coffee today, so I'm struggling myself. All right. Anyone have any questions before we move on to the, what was that? That was section
9.1.
9.1. Just section 9.1. All right, section 9.2 is really easy.
Yeah, that's good.
Right.
Last section was like,
We won't have to do any more major writing. So you guys are already familiar with section 9.2. Are you familiar with this concept? You ever heard of anything called the Pythagorean theorem?
Well, yes.
Yeah, that kind of rings a
I'm
bell.
not sure.
Yeah,
Right.
I've never heard of it.
That should ring a bell.
Never heard of it.
Attributed to Pythagoras, mathematician from a long time ago. I don't know.
How did he come up with like
From the long time ago.
so accurate? I'm so good.
A long, long time ago, there was a man named, I can still remember, there was a man named Pythagoras.
I'm wondering how he like came up with these theorems. Like how many times did he test?
I'm wondering how they came up with those names for the people.
For real, right? So we remember with the Pythagorean theorem, how do we normally label the hypotenuse? What letter do we use typically?
C.
C, so this is C, A and B, right? So the Pythagorean theorem basically says A squared plus B squared equals C squared, right? So we can figure out if we know we have a right triangle. It's only good on a right triangle. This is theorem 9.4. So I'm not going to write out the words for this one because I know you guys have seen it before. Theorem 9.4 is the Pythagorean theorem. In a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs, right? So that's super simple. And so that's what chapter 9.2 is all about. And like I said, we've seen it so much, I don't really think I need to spend any time on that. Does anybody not remember the Pythagorean theorem, and is anybody confused about how to use the Pythagorean theorem? It's okay, I can do an example if you want me to. But we're going to sort of do an example with the next section as well. So I think we'll see it. What we have after theorem 9.4 is the converse of the Pythagorean theorem, which is theorem 9.5. And that just basically, this is the converse. This is the Pythagorean theorem here. This is the converse of the Pythagorean theorem. And it just says if C squared equals A squared plus B squared, then if we were to label this triangle here, so that we had a triangle that was A, B, C, so that the angles opposite that side equal the capital letter of those letters corresponding to the side, then triangle ABC is a right triangle. So it just tells us that if we can prove that a squared plus b squared equals c squared, then we've proven that that's a right triangle. So if I didn't label this as a right angle, as long as the square of the longest side equals the sum of the squares of the smaller sides, then you could prove it was a right triangle.
So is the Pythagorean theorem only work for right triangles?
That's right. Now, that's a great segue, though, into the last two theorems, Theorem 9.6 and Theorem 9.7, which use the Pythagorean theorem to tell you whether you're dealing with, if it's not a right triangle, that the Pythagorean theorem can still tell you if you're dealing with an acute triangle or an obtuse triangle. Okay? So what Theorem 9.6 says is if c squared is less than a squared plus b squared, triangle is acute. And if c squared is greater than a squared plus b squared, triangle is obtuse. All right, so all of these theorems use the Pythagorean theorem as the basis for these other theorems. And all we have to remember is that C is always the longest side. Okay? So, for example, if I gave you these sides, I said I have a triangle that is this length, 38 feet by 77 feet by 86 feet. Is it right, acute, or obtuse triangle? Okay? So what am I going to do?
You take the longest side.
The longest side will be my c squared. So I'm gonna write this down. A squared plus b squared equals c squared. All right? So my longest side is my 86. So 86 squared, right? It doesn't matter which one you pick for A and B because we're squaring both of them and adding them together. So I'm just going to write it like that.
Then you just square everything and then.
And so what do I get? Who can tell me what 38 squared plus 77 squared is?
Not 86.
7373.
7373. 7373. And what is 86 squared? I'm going to let me do it in my head. 7396? Is that right?
Yeah, so.
That kind of hurt. I cheated, I looked in a book.
Oh.
All right.
I was like, what is the?
So this is the Pythagorean theorem. I should do that. I should come in. I should memorize all the numbers for all the problems for days. Just come in.
No, that would be so smart.
Yeah.
All right. So which symbol am I going to write in here? They're not equal. Right. This side is greater
Yeah.
than that side. So because my c squared, so what I really have is not this, not equals. I have this. So since the c squared is greater than the a squared plus b squared, what kind of triangle do I have? I have an obtuse, right? So does everybody see how we can figure that out? Make sense?
Yes.
Like I said, I could give you some lengths of sides and say, I just asked you the question, is this a right triangle? And if it is a right triangle, then these would be equal to one another. So you could tell me yes it is or isn't. I could give you a missing side, right? And say, what is the length of the other side? And you should be able to figure that out using the Pythagorean theorem if I tell you that's a right triangle. Okay? So that's it. And I will post your homework assignment online. And expect a test to be handed out next week for you to take home. Okay? Have a good one.